Okay, we'll look at some of the homework problems in section 8.1. Like in problem number 1, we're going to use the Pythagorean theorem to find the indicated quantity, and you're going to give the exact value. So here we have a right triangle. The hypotenuse is along the side of this triangle. That's 4. The length of one of the sides is 1. We want to find out what x is. Okay, if you recall the Pythagorean theorem, it's going to be this formula: a squared plus b squared is equal to c squared. Okay, that's the formula, but that's what we use for the Pythagorean theorem. A and B are the lengths of the sides. C is always going to be the longest side, which is your hypotenuse. Okay, I'm letting this be A. A is what we're trying to find. Well, it's x, so that's what we're trying to find, which is x squared, plus B, which is 1, and that's going to be squared, is equal to C, which is the hypotenuse, which is 4, and that's going to be squared. Okay, now if we simplify this, this will be x squared plus 1 squared is 1 times 1, which is 1, and that's equal to 4 squared, or 4 times 4, that's 16. So we got x squared plus 1, which is equal to 16. Then the next thing we're going to need to do is get the x squared by itself. And we're going to do that by subtracting 1 on both sides. So that means x squared is equal to 16 minus 1, which is 15. Okay, x squared is 15. We're squaring x. So the opposite of squaring something will be taking the square root on both sides. So that's what we're going to do here. Take the square root on both sides. So here x is equal to, now we just want the exact answer. In this case, the square root of 15. So when you type in your answer, this will be the exact answer that you'll type in using radicals. The square root of 15. Okay, problem number 2. Indicate whether the statement is true or false. The square root of 9 is an irrational number. Well, let's do this. If we take the square root of 9, can we find a number squared that will give us 9? We can. And in this case, it's 3. Because 3 to the second is 9. So the square root of 9 is 3. But 3 is a rational number because we can write this in the form of a fraction, 3 over 1. Because a rational number is a number that can be written in the form of a fraction, a over b. So in this case here, that answer there would be false. Square root of 9 is not an irrational number. It's actually rational. Problem number 3. Find the principal square root of the following number without using a calculator. Okay, now this number is 225. Okay, now you might think of this. If I write this as a prime factorization, I know that 5 can go into 225. Let's see, 45 times. I'll take that back. 43. 5 goes into 225. Let's see, 5 goes into 45 times. Okay. And then 45 is divisible by 5. That goes into 45 9 times. And then 9 goes 3 times 3. So if I wanted, let's say the square root of 225, that would be 5 times 5 times 3 times 3. But I know this 5 times 5, that's 25, and 3 times 3 is 9. And I know the square root of 25, that's 5, and the square root of 9, that's 3. 5 times 3 is 15. So the principal square root of 225 is 15. Okay. All right, problem number 4. Find 3 irrational numbers between 5 and 8, and you're going to select one of these answers here. Okay, irrational means that the They're non-terminating, non-repeating decimals. So A and C would not fit because those are terminating and repeating decimals. So A and C will not fit. Now let's think of this. Square root of 5, you're going to get 25. Square root of 8, that's 64. So square root of 25, square root of 64. Using the density property, we can find three numbers that are between the square root of 25 and the square root of 64. In this case, it will be these numbers right here. The square root of 42 is between the square root of 25 and the square root of 64. So it's the square root of 50 and the square root of 51. So it'll be this answer right here. Problem number 5. Determine if the given number belongs to the set. Like the number 1. Is it a natural number? Of course it is, because natural numbers start off with 1, 2, 3, 4, 5, and so on. If it's a natural number, then obviously it must be a whole number, because natural numbers is the subset of all your whole numbers. And if it's a whole number, it must also be an integer, because integers consist of positive numbers, negative numbers, and 0. And all integers are rational numbers because they can be written in the form a over b. Okay? If it's a rational number, it can't be irrational. You cannot have a rational number and an irrational number at the same time. Or a number can't be both rational and irrational at the same time. And all rational numbers and also irrational numbers must be real numbers. Okay? So, the only thing that the number 1 is not is an irrational number. Okay, let's look at this next problem. Determine for what real values of x, if any, the following statements are true. In part A, you got the square root of x equals to 3. Okay. Now, if you want to do this, you can think of the opposite of taking the square root of something, which will be squaring both sides. Or think of this. The square root of what number would give you 3? In this case, it's going to have to be 9. So the solution here would be 9. Well, the solution is x is equal to 9. Okay, part B, you got negative. Well, the square root of negative x is equal to 3. The square root of negative x equals 3. Okay, you can still square both sides of this equation. In other words, you're going to have negative x is equal to 3 squared, or 3 times 3 is going to be 9. Well, if negative x is equal to a positive 9, then that means that positive x must be equal to the opposite of that, which is negative 9. So that solution here would be x is equal to negative 9. Now you can check by replacing a negative 9 for x in the original equation. So here the opposite of negative 9 would be positive 9, and the square root of 9 is 3. Now look at part C, you got the square root of x equal to negative 3. Okay, you're going to have to think of this. There is no real number where you can take the square root of and end up with negative 3. Okay, so in this case, that answer there would be, there is no solution, because we can't find a number for x where you square it, you're going to end up with a negative number. Okay, next problem. Here we're going to write the following square root in the form of a square root of b, where a and b are integers, and b has the least value possible. And when you do this, you type in your exact answer using radicals as needed. So in this case, you got the square root of 150. Now, if we were to take the square root of 150, or if I write 150 like this, I know it's divisible by 2, so I'd use that 2 times 2 into 150 goes 75 times. And then we'll say 3 goes into 75 25 times. And then 25 is broken up into 5 times 5. So the square root of 150 is this. 2 times 3 times 5 times 5. But I know 5 times 5 is 25, so I'm going to bring this out. So I have 25 times 2 times 3. But 25 is a perfect square, so the square root of 25 is 5. And then the 2 and the 3 are not perfect squares. They remain underneath the radical. So here 2 times 3 will be 6. Okay, so here you're going to have 5 square root of 6 as the answer that you must type in. Now, you can think of a largest perfect square that would go into 150. In this case, it will be 25. And then 25 would go into 150 6 times. Okay? Number 8. A diagonal brace is placed in a 15-foot by 10-foot rectangular gate. What is the length of the brace to the nearest tenth of a foot? Okay, so here we have a rectangular gate. And let's say we put a diagonal brace here. It's not the best drawing. And it's a 15-foot by 10-foot rectangular gate. And we want to find out what this length here is going to be, which I'm going to call C, which is going to be your hypotenuse, because we're dealing with the right triangle here. So this is an application of using the Pythagorean Theorem. A squared plus B squared is equal to C squared. And I'm going to let A be 15 and B be 10. So this will be 15 squared plus B, which is 10 squared. That's equal to C squared. C is always your hypotenuse. Now 15 squared is 15 times 15. That's 225 plus 10 squared, or 10 times 10. That's 100. That's equal to C squared. 225 plus 10, 100. 225 plus 100, that's 325. That's equal to C squared. Now to find out what C is, we're squaring C, so the opposite of squaring C will be taking the square root of 325. Now, we're going to have to use our calculator to find the square root of 325, which will be, and it says to the nearest tenth, it will be 18.0. So, the length of this diagonal brace is 18.0 feet. And that's to the nearest tenth of a foot. Okay. And finally, number 9. We want to solve for x. Now here we got 10,000 raised to the x is equal to 100,000. Okay, I'm going to write 10,000 and 100,000 as powers of 10. 10,000 is 10 to the 5th. Because, no, I'm sorry, 10 to the 4th. 100,000 is 10 to the 5th. Okay, so here this is 10 to the 4th. And that's going to be raised to the power of x because I have the x there. is equal to 100,000 is 10 to the 5th. Okay? So now I have 10 to the 4x. I'm raising a power to a power, so I'm just multiplying the exponents. So that's 10 to the 4x is equal to 10 to the 5th. Now there is a rule that says here, if your bases are the same, I can set the exponents equal to each other. So I can set 4x equal to 5. And then divide by 4. X then will be equal to 5/4. Okay? So the solution that I'm looking for x will be 5/4. So here, this is one of those exponential equations that you're going to have to solve for x, and take the realization that if your bases are the same, then you can set your exponents equal to each other. So this should assist you with the homework problems in section 8.1.